So first, welcome everyone and thank you for coming today. As Bruce said, it's our first Kaggle competition and our first time to present in the Meetup. So if we did a really bad job, please forgive us. So around last year, August, to this year, January, we did this Kaggle competition called Two Sigma. And a big thank you to our team leader, Bruce, for helping us, as well as Archer for the great work, so that we can submit this competition. So starting from now, let's first look at the project summary. So our goal is to use the content of news analytics to predict stock price performance. We received two data sets. One is news data set. There are 9 million records and 32 variables. And the second is market data set, which contains 4 million records and 16 variables. Our process of dealing with this competition is that around 20% of the time we are doing data exploration, 60% of the time we are doing data cleaning, and another 20% of the time we were building a model. We actually attend this competition using Python in a very unique platform called Kaggle kernel, which is provided by a financial company called Two Sigma. The maximum memory is 16 GB, and with CPU cost of 4. So here it makes us a little bit difficult to get used to the platform and get used to the memory. The next, we are gonna talk about what kind of how the competition is evaluated. So with the data available, available data, we need to predict assigned confidence level with the interval from -1 to 1. So -1 means we think this stock gonna go down for sure, and 1 means we think the stock gonna go up for the next day. And every day a score of XT is calculated. And how it is calculated is listed here. So it's actually a sum of the confidence value, which is from -1 to 1, times the market return value, times a dummy variable. This dummy variable stands for 0 once it's not exist in the market, 1 if it exists in the market. And the training set timeline is from 2007 to 2018. So we have around 10 years of data to make the training set. And for the validation set, it's actually pretty interesting for this competition that the validation set starts after the competition, which is from January 2019 until July 2019. So the first the results gonna come out after July this year, and we will know who is the winner. And slides more? Yeah, slides more. Yeah. So after looking at the evaluation and project summary, let's look at what data we got. Here, there are two data sets. One of them is market data. Here is 16 variables in the market data. Time is a timestamp from 2007 to 2018. And asset code and asset name, which I want to emphasize here, is that one asset name can have multiple asset codes. So for example, let's say Disney company actually public their stock, but they public their stock in different countries. So different countries have different asset codes. Therefore, it leads to this result that one asset name, which is one company, would have multiple asset codes. And volume stands for how much volume trading on that day. Close means the closing price in the market. Open means the open price in the market. Now we can see from here to here, there are a bunch of variables called return variables. So I basically categorize all these variables into four categories in order for us to better understand. If the variable contains the word open, it means the value is calculated by open value. If the variable contains the word close, it means the return value is calculated by close value. Well, if the variable contains privy, it means it is making a comparison with previous market data. And if the variable contains next, it means the return is comparing to the future data. And one interesting thing I want to point here is the row and market. So row data means organic data, but the market data means the data is adjusted by the market, meaning the data is is considering the whole market movement takes the whole market movement into the consideration and calculates the return value. And there also, you can see the value 1 or 10 here. It means the time interval, either 1 day or 10 days. So let's actually look at some sample data here. We can open this web page in the Chrome. And when we actually look at the data, we found in the column which contains market value, there are a lot of new value, which means we actually don't know how the market as a whole could affect our stock value. Because here, as we can see, the return close privy market, we don't have any value of this. So in this computation, we couldn't actually take the market movement into consideration. Further, after looking at the data, we started to do the data cleaning process. So, yeah, go ahead.
Actually, can you go back to that graph you just had up? So am I understanding that this column is just blank?
It's not blank because it's sample data. It shows 100 data here. But if we open the full data, we find around 80% of this column is actually empty. So here is not much. We couldn't take much significance on these two columns. Mm-hmm. Yeah.
And can you scroll up a little bit? No, the other way. Yeah, that's right. So just so I fully understand what these columns represent. When it says returns close previous raw 1, this means that the return, you're comparing the close now with the close of yesterday of 1 day.
Yeah.
Okay.
Exactly.
But the goal of the competition is to predict the difference between the close and the open on a single day.
Right.
Yeah.
Right, on a
Okay.
single day.
Is there a column that has that information?
There's no column has that information, but at the end of the computation, we need to have a score. We need to have a confidence score. The score is between -1 to 1. So with this score, we can actually predict after a single day how the stock value will be. So let's go back to. Let's go back to this formula.
Can I have also another question?
Yeah.
Another question here. And what is the time frame for your prediction? So, okay, the stock will go up, stock will go down, and it's the time frame of that prediction, a day, 2 days.
I think it's a day.
Just one second day, or this day the stock will go up, yeah? The result.
10 days?
Okay,
Yeah.
just for 10 days it will go up, or for 10 days?
You're predicting 10 days in future.
I think so.
If you take T, you're predicting T plus 10.
Yeah, the 10 days interval, I think.
Okay, so going back to the empty columns again, if you can please for a second. Would it be fair to assume that you did not receive the data in that for those columns? That's why you couldn't do.
We checked the data, we checked 9 million of data, and we actually found a lot of missing value on these two columns.
So with that premise, if you're, since you have a time series of data, if you look at a day X, right? Could you actually not go day X minus 10 and look at data points for each of the days up until minus 10 and use those each data points aggregated as the previous 10 days move for the data that was missing in those columns?
Okay. Can you hear me?
Yes, I can.
Okay. Actually, like in this competition, when we cleaning the market data set, we did use the previous observed record. But the problem is like if the data points is like at the very start, at the very beginning of a time period, then we won't be able to use those previous days because there's no existing record, right?
Right, but that's where you learn.
Yeah.
So because where that is always going to be a start point.
Yes.
Right?
Yeah.
And so obviously for the starting day, you're never going to be able to look 10 days behind because you just don't have
Yes.
that data.
And in this case, in this competition, we will simply use the mean value of the return open or return close previous market and the return open previous market as a value to replace the missing value.
Right.
Okay. And did you get any sentiment?
Sentiment analysis will be in the news data, which I will talk further on.
Okay, cool.
Yeah,
Thanks.
no problem. So let's go back to the slides. We already had some touch points. So we already had a touch base on how we cleaning the data. For the market data, how we cleaned it with these 3 steps. The first step is we remove the data before 2010. The reason here is, as we all know, 2008, there's a financial crisis. And because of the financial crisis, the stock changed significantly. So we don't want to take this financial crisis into consideration into our model because we are predicting the stock value in 2019. So we actually exclude the data before 2010. And second step, we fill in the missing value. We have missing value open and close price. So we used the previous observed value to fill in those missing value. And lastly, we replace the abnormal data. So how we define the abnormal data here? First, if a stock is doubled from the morning until the market ends, then we will consider it abnormal data. Second, if a stock decreased to the half from the morning until the end of the market, then we will also consider it as abnormal data. We will also replace this data using the previous observed value. So, yeah, questions?
Sorry, just wondering, removing the data before 2010, was that like something people talked about doing widely? Like, did you see what happened if you had it in there, or was it just?
We actually saw a significant change for the stock price, and we have a kind of discussion with other groups, and they also exclude this part of data as well.
May I add a little bit about
Yeah,
some point in this part? The reasons that why we want to exclude the data before 2010 is mainly because of the financial crisis, of course, and also if you look at the stock price history, like from 2000 and the late 2009 and until now, we are actually in a bull market, which means the market is like go up in a trend. So, but if we include those data before between the period of 2007 and 2010, I consider that will make a effect on our prediction, because during that period of time, many stock, their prices go up and down a lot and fluctuate in a very considerable amount. But I have to confess that replacing those abnormal data by this criteria is unfair for some certain stock, especially the penny stock, because all we know we know that for penny stock, the value is around $1 or maybe more, maybe less. Their value can go up a lot in a single day, and it can be shrink to nothing in a single day. So but because we are considered that when people do investing, they will choose stock that the stock of a company that has a good reputation. So that's why we will still go ahead replacing those abnormal data by using this criteria, and hopefully that will give us a better a cleaner data set for our prediction and for the model building.
Any other concerns or? Okay. We will move on to the news data here. So the news data has, I believe, 4 million of data, but it has 32 variables, which is a large amount of variables that we need to deal with. Let's actually go into some sample to look at the data. I'm not sure if you guys can see here. So this is a news data, and the first column is time, which stands for when the data is available, and the source timestamp means when the news is come out. We have first created, source ID, headline is something I want to emphasize here, because in the next step, I will mention about we did some future engineering for news headline here. And this is something we consider that could be done into the modeling, but we didn't make it successfully. We could discuss more for the first several minutes. And then it got some other data, such as subjects, audience, body size, company counts, headline tag, and relevance. There are also some centimeter analysis data for the news, and I would like to pull out a descriptive analysis for the sentiment analysis. So this is several companies which has top mentioned negative sentiment, top mentioned neutral sentiment, and top mentioned positive sentiment. And one interesting thing we found here is that Apple company has the most negative sentiment and the most positive sentiment. So people who hate Apple hate a lot. People who like Apple love a lot. I guess that's the reason behind. As I mentioned, we tried to do a text mining, the future engineering for the news data. So we started trying this future engineering using the sample data, which only has 100 record inside. And this is word cloud we did. We exclude the stop words and symbols. This is what it looks like. And further, after the word cloud, we did, thank you. We used the IDA model to do the text mining. So basically, we put all this headline together and categorize this headline into 20 topics. There's still like more topics I haven't shown here. So we categorized into 20 topics, and for each topics, we assign a matrix which shows the relevance of the topic, relevance for each topic. For example, for this record, it has 1% relevance to the topic 0, 1% relevance to topic 1, 1% relevance to topic 3, so that we could actually make this matrix as another feature for the news data, so on we can put into the modeling. And the reason we haven't made it successful is because for the sample data, it's only 100 data record. We spend around 20 minutes to run the IDA model. If we need to run 9 million of record in this news data, it's gonna cost us 3,000 hours to run this whole data set. So we decided maybe we don't have that much time, and we decided to give up. But if anyone have any ideas or any suggestions, feel free to raise it. Maybe it could be input into the model in the future. So after that trying, we put the two models together. So what we used to link these two data sets together is we use the asset code and the time to put the market data and news data, combine them together. Further, we can build a model. And we calculate the average value in the news data so that we got this whole data set. And Arthur gonna talk about the modeling in their further step.
Okay. 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 Hello. My name is Archer. As you may have already known that we are first-time Kaggle practitioners, so we actually don't have too much experience in machine learning. So far, all the machine learning stuff I've learned so far is from neither Coursera by MGN, and also by some Amazon bestseller of learning machine learning with Python. Okay. So when I consider building the model, do you have a question? Okay, microphone. Can you hear me now? Okay. Okay. So when I consider building the model for this competition, since I don't have the expertise, so I want to use something that's really simple and doesn't consume too much computing power. Kishi, can you scroll down for one page? Okay. Yeah. Now, since for a data set this size, it usually consumes a lot of memory. So in our case, 17 gigabytes of memory through Cal isn't really enough, and also 4 cores on CPU isn't really help that much. And also we can only allow to use the Cal system for about 9 hours. So that's why I decided to use a simple model that will allow us to get the result quick and also get the result that is satisfying. So our task is to build a model that is easy to implement for machine learning beginners, and also can be trained fast without needing too much computing power, and also will be able to produce a satisfying result for first-time Kaggle practitioner. Then I decided to use a very popular method on pretty much all the Kaggle competition called the GBM, which is a tree-based model. It can be trained fast, and also it can be it's capable of handling scalable data, and also it's relatively easy to implement. And also there's another reason that why I try to use this machine learning algorithm is that for many stock, especially in a certain market, for example, if Google, Amazon, they are some kind of a techie company, so their price movement will more or less, related to each other some way. So they may tend to move into same direction. So which means if the stock of some companies that are doing a very similar stuff or within that particular industry, they may have a very similar return when it comes to the performance of the stock performance. So which means if we use a tree-based model, the company those companies may fall into a category, so which will assign a similar confidence values to them. So make it easiest for us to make decision making and also get the result that we wanted. So since we have a 9 million record, so if we set the train set to a rule of thumb of 50-50 or even 20-80%, the train set will be too large for us to get a result fast. So that's why I decided to set the train set at about 5% and then use the remaining 95% for the testing. And through this model, there's a couple of I pretty much leave the parameters of the machine learning algorithm at default, but set the feature fraction at 0.9 and also the backing fraction at 0.8. So in order to kind of drop out some of the weight of some certain branches. So we can see from this snapshot, our accuracy is just a little bit over 54%, but we did have a public score of 63%, which is already above 50% of all competitors on this competition. So we are quite satisfying with this result, and also it's not a bad score for K.
Do you know how the public leaderboard is calculated? On what data set?
The public data board, because we have to submit a file to the Kaggle competition, they will use the evaluation matrix to calculate the score. So and I assume the public score is the higher the better. Okay, but to be honest, I don't have too much information about that, and sometimes I just sorry. Just kind of submit a more as many as a model that we can produce, try to get a higher score. Okay, that's pretty much all we did in this Kaggle competition. So if you have too much competition and too much expectation of learning from us, then probably you would be disappointed. But the purpose of this presentation is that we really want to share our ideas so we can learn from all the experts here. Okay.
I have a quick. Okay. I just want to maybe throw out a theory, and you can comment on it as well as your question. Okay. So typically in Kaggle competitions, you get a public score that kind of gives you some sort of idea of how well you're doing on the test set, right? Yes. The test set being data that you've never seen before, the labels that you've never seen before. Yes. So in this competition, when the test set is essentially stocks starting in January, it seems like the public leaderboard can't be taken from that subset because it hasn't, I guess, happened yet, right? So theory would be that they've left some of the data out. Some stocks are not in your data set, and they evaluate on that. That's just maybe my thoughts.
Yeah, so I have a very simple question. I didn't understand the evaluation metric. Can you please, the evaluation metric, can you just repeat the explanation? I wasn't following. The evaluation metric, yeah, I didn't figure that out.
So the evaluation matrix is what we actually give to the competition is this confidence value, which is a score from -1 to 1. And then I think they will put into the value back into this formula, which is the confidence value times market return times this one is dummy variable. So normally the stock will be there for a long time because the stock won't suddenly disappear. So normally it will be 1. So it's basically the confidence value times the market return.
So I have a question. What's the market return?
Market return is given in the data set. So,
Oh, okay.
yeah.
It's given in the evaluation data set.
Evaluation.
Yeah, it's not. We won't be able to see.
I have a couple of questions. First of all, I'm trying to understand how the news component of that was presented to you. I guess you didn't have to do any of like web scraping or anything like that. It was given to you by Kaggle in some sort of like curated format.
It's given by Kaggle in the format that I showed before. So it's basically they use this kernel platform. And then they present the data on the kernel platform, and you don't have the access to export the data from the kernel to outside because they have the internal data they use.
Right, but what I mean is like in the kernel, you couldn't like access the internet from the kernel and get the news data from the internet.
Yeah, we could, but sometimes it's very hard for us also to see the full description of the data because it's big.
Too big.
Yeah, it's very big.
I mean, like, so what you're asking is like, can you repeat the question again?
Can you just like collect your own data?
Oh, no, because this Kaggle competition, in the rules said like we cannot like employ any expertise and knowledge from outside to modify the existing data set. We can only modify those data set based on the data set itself.
So it was just for this particular format.
Yes.
Yeah, and another question that I have is, have you explored any correlations between different companies?
Correlation?
Like, because if you know that there is like bad news about one company, you can infer that there is a bunch of other companies, especially if it's like a big company like Apple, for example. You can infer that there might be like 100 other companies that are likely to go down as well because they're in some way related to Apple.
Yes, that's actually a good point. Like, because like we actually like did a very little exploratory data analysis in this competition, and you are right. Like, companies like within the same industry, they will have some kind of like correlation, and also the stock price performance will tend to have a relation that is correlated to each other. So they tend to move in the same way. That's one of the drawback that one of the shortcoming of this the project we done, because we haven't looked deep into the correlation between each company, and also whether there's some interactive terms within the variable that will affect our prediction and our model. So and that's something that we really want to try, but since we spend lots of time like on gathering some idea about how to deal with the data set and how to try to learn something from the competition. So we unfortunately, we did not spend too much time like doing a exploratory data analysis.
All right, thank you.
Aspect.
One more question on this metric. Are you maximizing or minimizing it? Are you doing a maximization or minimizing this loss function?
We are not doing this.
It's just a summation.
We are not doing this mathematical calculation. We just offer the confidence value to.
Yeah, but that's the score. So is it when XT is very high, that's a better model, or when it's very low? Are you maximizing or minimizing it? So
we are not maximize or minimize it.
Well, this is like a knapsack problem if you look of some form. I don't know. Okay, that's fine.
I think you must be
maximizing.
Go for it.
I was wondering if you could elaborate like a little bit on how you merged the two data sets together. Because when I was looking at it yesterday, it was, I think one of them was 9 million data points and the other is 4 million. And I guess you have different times and different stocks. So like, how do you squeeze both of them into a single data set?
I will switch to that slide.
Merging the data set. Okay. On this, when merging the data set, we based on the SS code, as Kishi mentioned in the past, previously, because one company may have several different SS code, but pointing at the same company. So we will gather all the parameters from the market side, but in the news data segment, since one company may have or one SS code may have multiple news related to that company on a single day. So we will, for those numerical variable, we will just take the average of those values and then merge to the try to merge it to the
one single asset code
asset
in one
code.
single day.
And
on
then-
a daily basis.
And the news that you take for that particular company, it's only for that one day. So you don't look into the past with that, or I don't know how that would affect things, but so basically like a news article comes out on a single day and you only look at the stock, whether it goes up or down for that particular day?
Yes.
Yes.
How are you guys doing on time? Do you have a lot more slides to go, or is it okay?
Yeah, we have like
we still
4,
have
5 slides to go. I think we are good for one more question.
Yeah, you got
4 or 5, sorry.
So did you guys like treat data leakage, or did you guys like explore into that? Yeah. We're getting a lot of questions about the nature of the data and the leaderboard and stuff. Just to clarify a bit, a couple of things, see if I can remember all the things I wanted to say. But so just to be clear, the only raw text data you get is for the headlines. All the other stuff, the sentiment analysis and everything has been calculated for you. So you don't have any access to the raw data that's behind that. Another thing is you're running in this kernel environment, which is highly constrained. So you load a library that they give you, and that lets you do certain things to access the data set. You have no opportunity to access external data. The competition organizers were pretty clear that if you wanted to hack the leaderboard in this first part of the competition, easy, because you can just look up the stock and find out, it's public information, right, how the stock did in the past. But there's no point, because you're going to be evaluated on stuff in the future that nobody has seen yet. So data leakage, there's not that much opportunity for it. I don't remember seeing anybody talking about any kind of data leakage in this competition. Yeah. All right, that's what I had. Yeah.
Do I get it right that you've got this news data already sorted out for you and also almost like labeled, so it's like good or bad? You don't need to do any NLP like analytics on
Yeah,
stuff?
yeah.
Okay.
There's already centimeter, negative, neutral, and a positive score list in the data set. Yeah.
Should we continue on? Okay, and
One more.
oh, one more.
Yeah, I wanted to ask about how you kind of merged the single news articles. So like if on a single day there's multiple news articles, was it typical that they were all the same sentiment, or did you ever run into cases where there was different sentiment about the same company from multiple different sources, and how did you deal with that?
The way we deal with those sentiment, because I'm not so sure whether I'll be able to answer your question, but like in the this is the sentiment. No, not there.
I can show an example here. So actually, as we can see here, if we have a news called Press Digest, and this Press Digest news affect multiple companies like Walmart, Google, like Disney company, and under these companies, they have multiple asset codes. So this relationship is kind of like one news have multiple effect on multiple companies, and multiple companies have effect on those multiple codes. So maybe if one day there are two news come out, and a lot of asset code will actually get influenced. So while we merging the data, we combine it by asset code only, asset code and time in a single day. So in a single day, when two news happened and had effect on this asset code, we will take the average value of this, such as like relevance. We will take this average of these two values together into that record. I hope it helps. Yeah.
Thank you.
Yes, please.
Hi, so I have two questions. So the first one is, if anyone try to analyze this as a time series instead of taking every day like as an independent day. That's one question. The other one is, would it make any sense to train, like, I would suppose that those companies, they have like different natures. So would it make sense to train an independent model for every company or subsets of companies instead of trying to fit like one model fits all to like all the companies?
I think these two thoughts are all pretty great. The first one is time series. We actually considered about this at the beginning stage, but the thing is, how long it's gonna last? How long a news gonna affect this stock? We don't know that, and we need to actually do analysis for each single asset, which will take a much longer time. But if in the future we have this chance to have more time to dig into it, I think this would be a good idea to have a further analysis on that.
And also for the second part, you mentioned that like for companies that are all alike, for those companies that are very similar, in doing very similar stuff, you think we should like put a specific model for those companies. And yet, actually, that's a very good idea. But the problem is like if we have to do it that way, then we have to first of all, classify all the company and then and assign a category for each of for them. But in this but in the original data set, there's no variable that will allow us to categorize them. So which make it very difficult to do it that way. And also like the purpose of this Kaggle competition is to build a model that will, on the whole, will produce a result with all the existing value. So we didn't build multiple model to fit multiple company. Did I answer your question?
Just to throw an idea here, one might be able to do this by doing some unsupervised clustering of the companies. Maybe they will naturally segregate into very different types of companies, and then you would just fit a model to each one.
Thank you very much.
Thank you.
Should I continue on? Okay. And soon after we submit the first, make the first submission, and I on the kernel channel, and I heard the rumors that some people actually achieve a better result by owning the market data through some neural network things. So and that gives me an idea what would happen if we ignore the news data altogether and you try to use a shallower sequential model to build a model. Would this model will outperform the previous model and or also give us an idea whether the news data is really important to make the prediction. So can you go on? So in the next submission, we actually construct a very simple sequential model that consists of only three layers with using three activation function, and try to have a taste of like how it's going to perform. So, Kishi, can you move to the next slide? Okay. So in the another try, we built a very simple sequential model that consists of three layers, and we use two ReLU function, activation function, and also use the sigmoid function as the output for the output layer. Because we have to assign a value from -1 to 1 as a confidence value to indicate whether the stock will have a strong tendency to go up or down. So in the first glance, the sigmoid function doesn't seem to be a very good activation function because it only goes to 0 to 1, but not -1 to 1. So and that points out maybe a tangent is a better idea because it naturally go from a 0, -1 to 1. But the problem is since a lot of the factor will have a value that is greater than 4. So if we use the tangent as an activation function, so all the prediction value will be very close to -1 or 1, create a very broad, create a larger assign a lot of value in that two on the two sides, which doesn't mix. Which will affect the score. So that's why we try to use the sigmoid function to do the prediction, and then try to convert the prediction value from ranging from 0 to 1 to a -1 to 1. And the loss function that we use is very conventional. Which is pretty much it's a binary cosentropy. So it's a very popular loss function. It's different from the multi-square in the way that as the value of the value, the gradient close to 0, it will converge very the loss will, it will converge very slowly, so which will affect the performance of the model. But if we use this loss function, it will have a much better performance. And for the optimizer, we use the Atom, and we use the some parameter that is suggested by a lot of people, and also we will and after we submitted after we make a submission that using this model along with only the market data set, we did actually have a score a little bit higher than the previous one without all the headache of merging the two data set and try to figure out how to deal with the missing value after the joining. So on that, that implies a couple of ideas. Maybe go to the next slide. Okay. And the idea that we get from this from the two different submissions is that the price, it seems that the price movement is more correlated to the market data itself rather than the news data. But the problem is because we did very little to the news data. Because for example, when there's a news available for a certain stock, the market may not fully respond to that to the news, and the price may not be fully respond to the news as well. So in that way, our model seems to make and that lack of consideration in the lagging effects may cause our model put more weight on the market data rather than assign an equal way or very more balanced way between the market factors and the news data factor. And also after we merging the two data sets, there's too many missing data in the news data from the news variable. Because for those very big company, of course, we will heard a lot of news about them. But for those not very well-known company, especially those company doesn't have a very high value and doesn't list it on the S&P 500 or NASDAQ, there are not many news available to those company. So which means that after we joining the two data set, we found out for some of the variable in the data within the merged data set, there are over 50% of missing value in a single variable, which won't do us any good in the building of the model and also making prediction for the price. And also another reason that will lead to this result is that we did not really perform a exploratory data analysis to carefully select all the variables that will be related to the movement of the price, and also that the variables that will contribute to providing higher accuracy for the prediction, and also another major cause is that we both are inexperienced in building model and handling data. Because since before we decided to do this competition, I only have about 3 months experience in learning machine learning and try to figure out what the parameter, how the parameter works, and all the loss function stuff. So that also contribute to the result of the two submission. And the conclusion and the lesson we learned from this competition is that the model we produce is actually well, to be honest, it's not good. But I think it is good enough for a first time practitioner in Kaggle. And also we know that the model that we build probably assign a heavy weight on the variables in the market data set instead of the ones in the news data. So which resulted in the second submission, caused us to have a higher public score in the second submission than the first submission, which contains the news data. And the lesson that we learned from this competition is also for those competition that only allows practitioner to use kernel to compile compile the code. It is very useful to have a validation data set. So we can use a validation data set to test to try to validate our model more frequently, because in a more reproducible way. And also and the third point is that for beginners who are going to take part into the Kaggle competition, the kernel actually provide a very good starting point for us, because it gives us some ideas of which direction should we go, and also in the Kaggle channel we were able to receive a lot of usable information to improve our model as well, and also. And after this, we realized that the learning curve is very deep, and also the machine learning and deep learning stuff is not something that we can really, learn overnight. Obviously not through some kind of online education, only lasts about 4 weeks. Because I personally went through that, and I do learn a little bit about machine learning, but I don't think I will be capable of using using those knowledge learned from the online courses to apply it into my day job and to make contribution to my employer. So that tells me that in order to learn to master machine learning or deep learning, we need a more systematic way to learn. Maybe join a data science group like this one, because we have a lot of experts here, and also do some kind of more professional education, because recently I noticed that the heat of the machine learning is so hot. Like many people consider that we can like learn machine learning through in a short period of time through online courses, but I don't think it that way. So and that's pretty much about all the things we learn from this competition, and hopefully we have shared enough idea of our competition and our goal, and also we heard a lot of question from all the viewers, and we do appreciate your question, and because that will contribute to our learning path. So thank you very much for your listening.
Thank you. So I also want to add some points here, that I did my master in business analytics from UBC, but this Kaggle competition is totally different from what I learned in my academic journey, because in most of my classes, we got a data set from a really well-structured and organized data set from our professor. And we just need to apply the model, and we got the result. And finally, we realized, wow, I'm so capable with machine learning and everything. But eventually, it turns out that, all right, when we met the real-life issue, the data is not exactly what we are thinking about. It's unorganized. It has a lot of missing value. We need to think about a way to deal with this missing value, and we need to think about different solutions to solve it. So here we actually highly recommend you to attend a Kaggle competition, even if you had certain academic courses, but this one will give you a lot of taste of how data can actually input into the real life, the real
actually,
world.
like the data set is from Thomson, which is one of the very large
Financial
information provider alongside with Bloomberg. So in that data set, we still have like a lot of information that makes no sense. So which is more close to the real life situation. Like Kishi said, from the textbook and all the online resources, the data set is very well built. So when we apply the model, boom, over 90% of the accuracy. But that's not very easy to happen like in the real life.
Yeah, and thank you so much for everyone's idea and suggestions.
Any more questions?
Yeah, we have time for questions.
Just more like a general comment. Some of my friends actually did take part of this competition. Their comment was, because you have to train, your historical data is based on 2007 up to the very end of 2016.
Yes.
And the first stage right now is the performance of the leaderboard. It's based on 2017 to the end of summer 2018. And the general consensus was, it's very problematic because they didn't account for one of the most intangible variable, this person called Donald Trump. So because we're known like just one tweet can just single-handedly start trade war here, little rocket man there, Turkey problem, Iranian Middle East problem. So like the stock is going like crazy, and then the leaderboard is reflecting that kind of intangible, but it's not in the training data.
And also, I want to point out that, previous, last year, the Britain they actually exiting
Brexit, 2015,
right? And stock market in there may fluctuate even more than the one that we have in the U.S. market or in the Chinese in the Asian market. So it also created some kind of problem in the model building if we have to take it seriously, right?
That's why they're surprised to see not anything related to Trump. Mostly in the news data, but it's in the leaderboard, so it's heavily infecting your performance coming up. But people are just like, I can't model that. That's a black swan. So
I wanted to ask about the input for the predictions. So when you put an input in and try to predict the confidence -1 or 1, are you just inputting the single row with the different 1 day and 10-day differences, or are you inputting stock code and the model's taking into account all of the previous data for that stock code, or is it just that single record?
It should be the single record in my case.
Okay, I think I've got a question not for presenters but for audience. So, has anyone tried using Interactive Brokers API for stock market analysis? It's a broker that actually provides you an API, but you do need an account in there. Okay, I'm trying right now. That's why I'm asking, because it's like in Java and C++.
Yeah, pass you.
So I guess I may have missed it, but which particular exchange did you get your data set from? Like, I know it was from Thomson Reuters, but did they provide from NASDAQ or NYSE or TSX or?
Actually,
Or was it
contains
multiple
all-
exchanges providing?
Yeah, multiple
Because
exchanges.
one stock could be traded in two different exchanges, right?
Yes.
And there is just no.
Yes, actually, the stock from the ticker, we can see the information that we receive is from multiple exchange. It's not only the U.S. market, but also in the European market and Asian market. So it's pretty much a total market, total global market.
Interesting. And do you, for a particular stock, having different stock symbols in different markets, do you factor in the arbitrage as well then? Or?
I didn't. Sorry.
Okay.
So I was just going to ask that, so given this particular problem with the public leaderboard, where I guess it would be possible to score a perfect score on it, does that mean that at this point you are not able to form an understanding of maybe like what solutions other people did and maybe what might be best? Like, is it just completely unknown at this point who's gonna perform? I'm getting nods from Bruce. Yeah, wow. Will there be any kind of like iterative release of the private leaderboard? Like, obviously some of 2019 has passed. Do we have like current leaders on the private leaderboard?
I think like
We
the whole
do
the score won't be I mean like the leaderboard won't be public. The final result.
So yeah, but these scores are quite probably bogus, right? But the private, like, is there, like in the past when they've had like future dated like private leaderboards, you know, they did like after a couple months they updated and then a couple months later. I guess there's none of that at this point. Yeah.
Yeah,
all shrugs.
Curious too.
Yeah,
Okay.
probably the private leaderboard will be available like when the competition ends.
And July 2000.
Yeah, it could be continuous. How much prize money is involved in this?
It's a lot, I guess.
$100,000.
Oh.
$100,000. Yeah. Oh, it's like 25,000 for the first place, 20,000 for the second place, and 15,000 for the third place.
Yeah, so total $100,000.
Yeah.
Hello. I have a question about your finding that looking at market data only actually improves your predictions. Can it be because of the nature of the evaluation metric, that it is actually the mean value of the score over some time period? So the effect of news is kind of negated over like long time period. Like what's your explanation why considering market news does not really improve your scores?
Now, the first reason is that first of all, when we because there's for the first model we use the news data, but there's too many like a missing value in the from the news data set size. So when we compile the first model, the model probably put a heavier weight onto the market on the value in the market segment instead of like assigning some reasonable amount of weight on the variable in the news data set. That's reason number one. And also as I mentioned about, because we did in our model and in our exploratory data analysis, we did not taking account for the lagging effects for in the news. So that pretty much makes the news less useful as it is, because we know that sometimes the markets is they react very slow, especially unless there's some very big news from for example, the federal government, which will have a global effect on the stock market. And in that, so in other case, which means like for some very like a small news, the stock may not be fully responsible to the news stock immediately. Without the considering those effects, the accountability and from the variable from the news data set is like less useful, less than what it should be.
Sorry to interrupt you, but what I'm trying to ask, if instead of your evaluation metrics that you guys were using, in your evaluation metric, it was actually averaging over several days. So if there were no averaging, if the evaluation metric would be asking for confidence value on a specific day rather than average over some time period, do you think news would have a larger effect?
That's a tough one. So what you means like if we assign the value on a single day instead of like over a period of time, would that be able to make the model better perform?
Right. I'm just curious if it is just specific for this competition because they have because of the way they average the confidence value over several over several days.
Yes, 10 days.
10 days.
Yes.
I would consider maybe there's a possibility, but as I think one person mentioned that making a time series model, include a time series model about how long the news is gonna have effect on the market, on each stock, would give us more accuracy. Like the news could give us more information if we can set a certain time period. Yeah.
Hey guys, that was awesome.